So for the first question on the Chapter 6 review, it's one of those where we're given, the 3 bits of information. We have an initial condition, 125 gallons at time t equals 0. We have a rate in, and then we have a rate out as well. And so as we read each of these questions, it's super important that we pay careful attention to think about, okay, which of those 3 pieces are we talking about? And so in part A, it says how many gallons of heating oil are pumped into the tank. So I don't care about how much goes out, and I don't care about how much I started with. I just care about how much goes in. And since this is a rate, h of t is given as a rate, then if I want to know how much has accumulated, what is my net change, in other words, I just use a definite integral here. So for part A, should be the definite integral from 0 to 12 of h of t. And we would just go ahead and do that on our calculator. And you'll get about 70.570. Part B, nice contrast here. I was getting ahead of myself. I was looking at part C. Is the level of heating oil in the tank rising or falling at the time t equals 6 hours? Give a reason for your answer. Well, the amount of oil in the tank is going to be rising if it's going in faster than it's coming out. And so we just have to see what is the value of h of t and what is the value of r of t at t equals 6. And if we do that, I'll just say h of 6 is less than r of 6. So the level of oil is falling. And there's a couple ways you could actually determine that. One is to graph them both, just see which one is bigger, which one is smaller. You could subtract h of 6 minus r of 6, see do you get a positive or a negative answer. I think those would be the 2 most common ways to do that. Part C, how many gallons of oil in the tank at time t equals 12? Well, in this case, we need all 3 pieces. I need to know how much did we start with, how much did we add, and how much did we lose. And so to put all that together, I'm going to do it as 3 separate pieces. I'm going to say my total is going to equal 125 plus the integral from 0 to 12 of h of t minus the integral from 0 to 12 of r of t. This should have a dt, and so should this, sorry. And if we do that, we'll get 122.025. They didn't ask us to justify or anything, but a lot going on there. Again, you have to think about all 3 pieces. How much did I start with? How much did I add? How much did I lose? Gives me that much in total. All right. If you need to pause at this point, go ahead, because I'm going to erase everything we have here on the screen. So pause and write it down if you need to. Part D, at what time is the volume of the oil the least? Well, this is sort of an optimization problem here, or it's not even quite that. It's just finding a maximum or a minimum. I'm looking for the least. And so I know that this least value can occur either at a critical number where the derivative is 0 or undefined, or an endpoint 0 or 12. And so the first thing I'm going to look at is what are my critical numbers. So I'm going to say my critical numbers, of course, back up just a little bit, are where the derivative again is 0 or undefined. And since h of t and r of t are the rate at which oil enters and leaves, and we're talking about the amount of oil, the volume of oil being the least. So h of t and r of t are the derivative. So we're looking for where does h of t minus r of t equal 0. And that happens at two different places. You're going to get t is about 4.790 and 11.318. And those are the places within the interval from 0 to 12. And so I need to know, okay, well, are we one way to think about this is to say, okay, well, what's happening between 0, because if I set up my number line here, I've got 0, 12, those are my endpoints, and then I've got this 4.79, and then this 11.318. And so if I look at this overall derivative and see where is it positive, where is it negative, I'll be able to figure out when my minimums are. And I can see that if I look at the graph, h of t minus r of t is positive here, positive, and then it's negative here, negative, and then it's positive again. So I know that my only possible minimum would be either at 0 or at the 11.318. Because wherever I'm at 0, which actually I know is 125, I increase until here. And then I decrease until 11.318. Well, did this decrease for almost 7 seconds? Did that bring me down less than my starting value of 125? Or was it decreasing slowly enough that it's still above the 125? I'm not sure. But then over here, we're just going to increase again. So the value at 12 is not really relevant here. So I just need to figure out how much do we have, how much oil do we have at 11.318? And we're going to do that the same way that we did part C. So we're going to say 125 plus the integral from 0 to 11.318 of h of t. And I'm going to smash it into one integral here, mostly because I'm running out of room, but also because we can, and we did it the other way the first time. And if I do that, I'm going to get 120.738. So it did decrease enough, just barely enough, to get below that initial value, and so that is my minimum. So my answer, because the question says at what time t, so 11.318, and in this case they just want us to show our analysis, so what we've shown here is good. We didn't have to justify. All right, so that's number 1.